Hi everyone, so we're going to finish up our notes with ecosystem ecology, talking about some disturbances that might happen within these ecosystems. So let's define what that is. A disturbance is any event caused by physical, chemical, and biological agents that changes the population size or community composition. So these disturbances can either be natural or anthropologic. And when I say natural, I'm usually going to be talking about earthquakes, fires, volcanic activities, disease within animals and in plants, anything like that. And then more anthropologic might be deforestation, pollution caused by humans, and other different factors like that. All of those can be considered disturbances. And even just overhunting can be considered a disturbance as well, because removing one species, as we know with our food chains and our food webs, can really affect the ecosystem as a whole. So two things we're going to talk about here is resistance to disturbance and resilience from disturbance. So resistance is a measure of how much disturbance can be affected before it affects the flow of energy and of matter. So how much you're actually going to see the impact of this disturbance before it changes the ecosystem. Resilience is going to be the rate at which the ecosystem returns to the original state after a disturbance has changed that ecosystem already. And then last thing we talk about here is restoration ecology. So this is really the help to bring that ecosystem back to where it was, restoring that damage that was caused by either man-made disturbances or natural disturbances as well. So restoration ecology is really important. We do see it as well when we have stable environments too. So sometimes in special forests, you might need some water cleaning, you might need some healthy tree cutting and releasing of some of that material, and that's what restoration ecology is all about. So for ecosystem services, with this idea of restoration ecology, we can see that intact environments provide some services that happen, and those can include water purification and pest control, healthy cutting as well. High biodiversity is also going to increase the stability of these communities. So when I say high biodiversity, I mean a large amount of different types of species in both our plants and our animals. And those are going to help maintain that ecosystem and maintain that stability. And because of this, our stable ecosystems are going to be resilient and resistant. So when I say that again, let's review what those mean. Resistance is is resistance to change without losing the function of that ecosystem. So whether or not it can adapt to those quick little changes really fast without losing the function of that ecosystem. And then resilient, we're going to talk about that affected change, but bouncing back and regaining the function after that change has occurred. So only stable ecosystems, we're really going to see this. If we have an unstable ecosystem, it might be changed forever and no longer be able to come back to its original function. And you'll probably see more of those in places that have been clear-cut and taken over by humans. Last thing I want to take a look at is this graph here. So are disturbances good for an ecosystem? So if we take a look at this graph here, we can see on our x-axis, we're moving from infrequent to frequent disturbances. And on our y, we can see the number of species rather low or high. So if we follow along this axis, our line here, we can see infrequent disturbances are going to correlate to low species diversity. High and frequent disturbances are also going to show for a pretty low number of species in an environment. But at this nice level here, we can see at an intermediate disturbance, we do see the highest amount of organisms or species allowed in that area. So some disturbance is good because it allows that change in that evolution of that ecosystem, but too much is going to make you lose species, and not enough is also going to cause a low number of species. So definitely be able to interpret graphs like this, and if you have any questions, please feel free to reach out.